All right, let's keep going through the review. Here we pick up at questions in which we simplify a square root. So if you used a factor tree on the square root of 64, you would end up with everything pairing up, and that's because 64 is itself a perfect square. So first of all, we pull out I. We cannot take a square root of a negative. And so I times the square root of 64. 64 is itself a perfect square. The square root of 64 is 8. So 8 times I, or I times 8, we'll just call it 8I. Now, here we have the square root of negative 63. Again, we pull out I, but 63 is not a perfect square. So we'll take 63 and do a factor tree. 63 divided by 3 is 21. Cross out each factor as you go. 21 is 3 times 7. And it does not break down anymore. So our 3's paired up, and the 7 stays under the radical. So again, if it pairs up, move one of them outside of the radical. Anything that doesn't pair up has to stay under. So 3I root 7. If you see one without a negative under the square root, then we don't have to pull out I. We just break down 50. That's 2 times 25. And then 5 times 5. So again, if it pairs up, write one of them outside of the radical. Anything that doesn't pair up stays under. So you'll have a couple that just involve simplifying a radical. And then we get into the solving quadratic equations. First, we will solve by factoring. Here, we are looking for factors of negative 36 that combine into positive 9. And again, we can split up the middle term doing so. So factors of a negative 36 means we're looking for a difference. So what makes 36? There's 18 times 2, and then 9 and 3. 9 and 3, I'm sorry, 12 and 3. Pardon me this morning. Positive 12, negative 3. Combines into positive 9. But positive 12 times negative 3 makes negative 36. So we can split up our 9x by calling it 12x minus 3x. And then just bring down everything else. And we can factor by grouping here. I think that's the method most students are telling me that they use. So we pull out here a GCF of x, leaving us with x plus 12. Here we factor out our negative 3. So we bring down the negative sign, and then 3x and 36, the GCF is 3. Negative 3x divided by negative 3 is x. Negative 36 divided by negative 3 is positive 12. Our factors matched. That's an indication that we worked this out correctly. But on the test, make sure you don't stop here, because it asks us to solve. So we factor, and then we take each factor and set it equal to 0. And then we just have two small equations here. Subtract 12 from both sides. There's a solution. Here we add 3 to both sides. Oops, x equals 3. And those are the two solutions. You can put them in a solution set or just kind of box your answers. Either way is good. If you just hate factoring, but you understand the quadratic formula, you can just use the quadratic formula here, where a is 1, b is 9, c is negative 36. And I'll give you, most credit. But again, if it's factorable, your radical will disappear entirely. And you'll get a fraction that you'll have to split up to get your two answers. So you'll have a question in which you are asked to solve a quadratic by factoring. The last one we'll look at in this video is number 30, in which we are asked to solve using the square root method. So we'll look at 30 here. I have a binomial squared equals 16. So x minus 2 squared equals 16. The square root method says that once you have your squared piece isolated, take the square root of both sides, knowing that over here it's positive or negative, just like it is in the formula. So squaring and square rooting, these are like opposite functions. So x minus 2 is now by itself equals plus or minus the square root of 16, which is 4. So again, don't forget to do the plus or minus on the right side. I know that was kind of hard to read, but that's what we did. Put the plus or minus in front and then take the square root. So here, fortunate enough that we had a perfect square. The square root of 16 is 4. And so now, don't stop here. Set this up as x minus 2 equals positive 4 and x minus 2 equals negative 4. Because that's the plus or minus giving us our two answers. Add 2 to both sides. Add 2 to both sides over here to get negative 2. And these are the two solutions. So next we'll look at completing the square and solving the quadratic formula.